Hello students, I hope that you are good, well and fine. In today's session, we will be seeing NCERT exercise 7.4 solution. Okay, so let's see the first question of our 7.4 exercise. So integrate 3x square divided by x power 6 plus 1. Okay, you have to evaluate it. So let's see that how we are going to evaluate it. Okay, so first of all, the first thing is to use the substitution. Okay, so put x cube is equals to t, then you will have 3x squared dx is equals to dt, which means that your this what your your numerator your numerator your numerator is now can be replaced by just dt. Now can be just replaced by this dt. Okay, as you can see from this substitution, you will get 3x squared dx is equals to dt. Okay, now your denominator will be what? This x power 6 can be reduced to x cube power square. This means t square. You will get in denominator t square plus 1, and you know 1 by t square plus 1 integration is just nothing but tan inverse. So it must be tan inverse t plus some constant, and replace that value of t back, you will get your final answer as tan inverse x cube plus some constant. Okay, clear? Let us move to the next problem. Now 1 by root of 1 plus 4x square. Now remember the form that we learned about integration of 1a square plus b square something, or x square plus a square, or a square plus x square form. So we will be using that. So here you can see 1 square will be 1, so 1 square plus 2x whole square. So this form can be reduced like that. Okay, so this means what? That you can have what? So taking as 2x is equals to t, you will have 2 times of dx is equals to dt. This integration now reduced to this form. Now we can easily evaluate this form, and we know the direct integration formula, that it will be log of log of t plus root of t square plus 1 plus some constant. Okay, why? As you can see from here, that 1 by root x square plus a square dt is equals to log, so it must be x here. Okay, dx. Okay, log of modulus of x plus root of x square plus a square. Okay, and just replace back just substitute back your value for t in terms of x. You will get what as your answer? As this. Okay, simple. I hope it is clear to you. Let us move to the third problem. 1 by root of 2 minus x whole square plus 1. Okay, so we will use the same thing. So put 2 minus x is equals to t. 2 minus x is equals to t. Now dt is equals to minus of dx. Okay, dt will be minus of dx. Now this integration is reduced to minus of integration 1 by root t square plus 1 dt. And we know, we just saw this direct integration, which will be just a log of modulus t plus root of t square plus 1 plus some constant minus is already there. You will get this. Okay, we use this thing, that integration of 1 by root x square plus a square dt is equals to log of modulus of x plus root x square plus a square. Okay, now substitute back your value for of t in terms of x. You will get your answer in terms of x. So, and using the log property, you will get this as your final answer. Okay, let us move to the fourth problem. Now fourth problem says that integrate this. So taking 5x is equals to t, you will have dt over d multiplied dx will be now what? This equals to t. This means this 25 x square can be rewritten as 5x whole square, and this 3 can be rewritten as 3 square. Okay, so you will have, after using this substitution, you will have this as a simplified integral. Now 9 can be rewritten as, again, in what form? As a 3 square. Also here it must be root. Okay, root. Now 9 can be rewritten as a 3 square, and t square is already there. Now this is of form what? Integration of 1 by root a square minus x square, and we know the direct integration will be sine inverse of x by a, which is t by 3. Now t is what? 5x. So substitute back your value of t in terms of x, you will get your final answer. Okay. Fifth problem. Fifth problem says 3x divided by 1 plus 2x power 4. Okay. Now root 2x square is equals to what? Okay. You will have put it equals to t, then derivate it. What you will get? You can directly get 2 root 2 x dx is equals to dt. Okay. Simple. This means this integration can be simplified as 3 can be taken out of the integration. Okay, and 1 plus 2x power 4, this can be rewritten as 1 plus root x square whole square, and we just took root x square as t, so this will be changed into 1 plus t square. That's why we have written over here. Okay, clear. And after substitution, this dx can be replaced by this 2 root 2 thing. Okay, I hope it is clear to you. Now the integration for this part 1 by 1 plus t square is direct, just nothing but tan inverse of t by a. Yes, I hope it is clear. So this is just tan inverse t. Now replace the t back. Okay, in terms of x, you will get your answer as this. The final answer will be 3 divided by 2 root 2 tan inverse root 2 multiply x square, and then plus some constant. Okay, let's see sixth problem. The sixth problem says integrate x square divided by 1 minus x power 6. Now taking x cube as your t, so putting x cube is equals to t, you will have dt is equals to what? Dt is equals to 3x square dx. Okay, this means you can replace your numerator. First of all, you can replace your numerator by dt by 3. Okay, and then denominator by 1 minus t square. As you can see, 1 minus t square and 1 by dt by 3. Now you know the direct integral for this. You just saw in the theory class that integration of a dx a dt by 1 minus t square will be what? Quite simple. Half of log modulus 1 plus t divided by 1 minus t plus some constant. Substitute back value of t, you will get 1 plus x cube 1 minus x cube. So this will be your final answer. Okay, let us move to the seventh problem. Seventh problem says integrate x minus 1 root of x square minus 1. You will get what? Quite simple. Okay, so so this will be what? So first of all, separate it. You will have x divided by root of x square minus 1 dx minus integration of 1 root of x square minus 1. You know the direct integral for this thing. Yes, you just saw in the theory class. And for this integral, you have to substitute what? X square minus 1 is equals to t, as you can see. Okay, so putting x square minus 1 is equals to t for this integral, you will have 2x dx is equals to dt. This means this integral is now transformed into this integral half of integration dt by root t, and you all know half of integration dt by root t is just nothing but what? As you can see, the root t can be rewritten as t power minus half. This means using the integral rule, you can get half of 2 times of root t. This means just root t. Root t means substituting back your t value, you will get your final answer as this for this integration. Okay, we are talking about for this integration only. Okay, now the second part. Now to evaluate the second part, we know the direct thing, which is integration of 1 by root x square minus a square is just nothing but log of modulus x plus root of x square minus a square, this thing. We will be using just this thing. So after using this thing, you will get your final answer as this. Okay. So you must know about these, okay, about these direct integration. Without them, you will face difficulty or you will take more time, okay, comparatively. Clear? Okay, let us move to the next problem. Now, same thing. 6 x cube can be taken as t. So putting x cube as t, you will have dt is equals to what? 3x squared dx. Now what? Now this integration now change to uh, because of this substitution, x cube is equals to t, you will have dt by 3 root of t square plus a cube square. So this is the form like 1 by integration of 1 by root of t square plus a square. So you will have what? Log of t plus root of t square plus a square plus some constant. Okay, now substituting back your t in terms of x, you will get your final answer as 1 by 3 log x cube plus root of x power 6 plus a power 6. Also some plus some constant. Always add some constant. Okay, let us move the ninth problem. Now this. As you know, if you take 10 as your t, then you will have derivative of 10 will be what? Sec square dx is equals to dt. So you can directly replace your numerator. So 10x is equals to t. 10x is equals to t. This means dt is equals to sec square dx. This means this sec square dx now can be replaced by just simple dt. Okay. And in denominator you will have root of t square plus 2 square, and this is what form? Integration of 1 by root t square plus a square. You will have log of modulus of t plus root t square plus 4 plus some constant. Okay, clear? After substituting back your t, you will get your final answer as log of modulus 10x plus root 10 square x plus 4 plus some constant. Okay, clear? I hope it is clear to you. Let us move to the 10th problem. Now 10th problem says integrate 1 by root of x square plus 2x plus 2. Now what thing we have to do? The making the complete square. Okay, so how you can do that? Quite simple. So you'll see x square plus 2x plus 2 is just nothing but x plus 1 whole square plus 1. Okay, how we get it here? Quite simple. Okay, so whenever you have to make complete square, how you can make is quite simple. First of all, what? If you remember that from the theory class, okay, if you remember the theory class, we have already given you how to make complete, or how to complete the completing square method. So using that method you will get x plus 1 whole square plus 1 square. Okay, now substituting x plus 1 is equals to t, you will have dx is equals to dt. Okay, dx is equals to dt. Now your complex integration, which is this, now change into, transform into this simple integration of 1 by root t square plus 1 dt. And we know the direct integration for this. Okay, we know it, which is log of modulus t plus root t square plus 1 plus some constant. Substituting back value of t in terms of x, you will have log x plus 1, okay, plus x plus 1 whole square plus 1 plus some constant. So the final answer will be this. Okay, clear? I hope it is clear to you. Let us move next. Now 11th problem. 11th problem says 1 by 9 square plus 6x plus 5 integrated. So integration of 1 by 9x square plus 6x plus 5, okay, dx is equals to integration of the same thing we have to apply using the completing method square. Okay, you will get 3x plus 1 whole square plus 2 square. Okay, and from here you know that take this inside thing, the x term, okay, as equal to t, you will get what? You will get 3x plus 1 is equals to t. Now differentiated with respect to x, you will have 3 times dx is equals to dt. Okay, so far so good. Now you are having your expression as integration of 1 by 3x plus 1 whole square plus 2 square dx is now transformed into 1 by 3 integration of 1 by t square plus 2 square dt. Yes, now we know that integration of 1 by a square plus t square, which is just in terms of tan inverse. Yes, okay, so which is 1 by a tan inverse t by a plus c. Okay, so 1 by 6 tan inverse 3x by 3x plus 1 by 2 plus some constant. This will be your final answer. I hope it is clear to you. Okay, now 12th problem. Integrate this 1 by root of 7 minus 6 minus x square. Okay, so integrating this, what you can get is quite simple. Okay, just nothing but do the respective what, perform these steps. What steps? That first of all, make this term, this denominator quadratic expression in terms like this, some a square plus some b square like this, and take x term is equals to t. Okay, now differentiate it with respect to x, you will get some like this thing. Okay, and then you have to apply whatever the formula is. Okay, so I hope that it is clear to you. Okay, I hope that you can easily do it by your own. Let us move to the next problem, problem number 13. Now 1 by root x minus 1 x minus 2. So how you are going to solve this? Quite simple. So first of all, this can be rewritten as x square minus 3x plus 2. Okay. Now this is equals to x square minus 3x plus 9 by 4 minus 9 by 4 plus 2. This makes completing square, okay, which is x minus 3 by 2 whole square minus 1 by 4. This means x minus 3 by 2 whole square minus 1 by 2 whole square. Okay, now this your original integration now transform into this form, okay, using completing square method. Now take x minus 3 by 2 is equals to t. You will get what after differentiating? You will get dx is equals to dt. Okay, now integrate 1 by root of x minus 3 by 2 square minus 1 by 2 whole square dx is equals to what? Integration of 1 by root t square minus half of square dt. And you know the direct integration for this 1 by t square minus a square form, which is just nothing but log of t, okay, log of t, okay, log of t plus root t square minus a square thing. So your answer will be what? Your final answer will be, okay, your final answer will be what? Log of, in terms of x, your final answer will be log of modulus x minus 3 by 2 plus root of x square minus 3x plus 2. Okay. So I hope that you are getting that how we are using the completing square method. Okay. Let me just show you a solution for 14th problem. So the same process will be done here. Okay, so x plus 3x minus x square can be rewritten as, first of all, x minus x square minus 8 minus x square minus 3x plus 9 by 4 minus 9 by 4. This means you will have what? 8 minus x square minus 3x plus 9 by 4 minus 9 by 4, and this can be rewritten as x minus 3 by 2 whole square. This term, this inside term can be rewritten as what? X minus 3 x minus 3 by 2 whole square, and this x and minus minus will become 9 plus, so 8 plus 9 by 4 will be 41 by 4. Okay, now this given integration is now transformed into this form, which is 1 by root a square minus x square form. Okay, so substituting x minus 3 by 2 is equals to t, you will have dx is equals to dt. You can directly replace dx by dt and other term by t. So 1 by, your expression will be now, your integration will be now 1 by root of root 41 by 2 whole square minus t square. This is what form? 1 by root of a square minus t square. So this is just nothing but sine inverse t by a. And this means what? Sine inverse 2t by root 41 plus some constant. This means replace your t back. What you will get? Sine inverse 2 times of x minus 3 divided by root 41 plus some constant. So your final answer will be this. Okay, clear? I hope it is clear to you. Okay, so if you memorize these direct integrals, okay, direct answers, so the integration will be very easy for you. Okay, let us see the next problem. Problem number 15. First of all, what you have to do is multiply them. After multiplying, you will be getting some quadratic form. That quadratic form can be changed into some x term whole square minus some y constant term whole square, okay, or x term whole square plus some constant term square in this form. Okay, and you know, after substituting you will get the direct formula. Okay, I hope that you can do it easily. Okay, let us move to the 16th problem. Now 16th problem says integration of 4x plus 1 root 2x square plus x minus 3. Okay, so this will be 4x plus 1 is equals to, now whenever you have such type of question, in denominator you are having root of some quadratic expression, and in numerator you are having some for px plus q form, which is 4x plus 1, then you have to do what? Always pick the numerator is equals to derivative of the thing inside the root. Okay, so as you can see, 4x plus 1 is equals to a times of derivative of a thing inside the root plus some constant b. So you will have 4x plus 1. So this will be 4x plus 1 is equals to a times of 4x plus 1 plus b. So this means you will have, by just distributing a and comparing the coefficient, you will have 4a is equals to 4. This means what? 4a is equals to 4. So comparing what? We are comparing this 4x. The coefficient of x we are comparing with the coefficient of x, and the constant term we are comparing with the constant term. So you will get what? You will get a equals to 1. If a is 1, then b will be 0. Okay. Why? Because a plus b is equals to 1. So this means b will be 0. This means you will have 2x square plus 3 minus 2x square plus x minus 3 is equals to t. You will have this. Okay. Clear? I hope it is clear to you. Okay. So what you have to do is quite simple. Okay. So you can take 2x square plus x minus 3 is equals to 2. Okay. Now what? So dt will be 4x plus 1 dx. Okay. Now what? Now this can be easily replaced by the numerator can be replaced by just dt. Okay. And this will be just nothing but root of t. Okay. And 1 by root t integration is just nothing but root t by half. This means 2 times of root t plus some constant. This means 2 times of root of 2x square plus x minus 3 plus c. Okay. I hope it is clear to you. Simple. Okay. So what we used is this information that we arrived at, that 4x plus 1 can be written as 1 times of 4x plus 1 plus some 0. Okay. That's why we can easily substitute our denominator equals to t. Okay. I hope it is clear to you. So as we do not have, okay. So let me just solve the next problem. This problem number 17. So let us just quickly see the solution. So putting x plus 2 is equals to a times of derivative of the denominator thing, denominator root inside the root thing, you will have what? X plus 2 is equals to a times of 2x plus b. So compare x coefficient with x, you will have a is equals to half and b is equals to 2. So a is equals to half, b is equals to 2 you will get. So from this you will get x plus 2 can be rewritten as half of 2x plus 2. Okay, so rewrite your numerator in this form. You will have what? Half of 2x plus 2, and this will benefit that after you get this replace, okay, separate them, you will get what? You are integrating expression as half of integration of 2x divided by root of x square minus 1 plus 2 divided by root of x square minus 1 dx. Now taking this as t, you will get what? You can directly replace your 2x dx numerator by just dt, and you will have your integration as half of integration dt by root t. After simplification you will get just equals to root t, and root t substitute your t value, you will get root of x square minus 1. Now integration for the second part, you will have integration of 2 divided by root x square minus 1 dx. This can be directly evaluated by just using log, and it will be equals to 2 log mod x plus root x square minus 1. So you will have final answer as root of this x square minus 1 plus 2 times of log modulus x plus root x square minus 1 plus some constant. Okay. Now let's see the 19th problem. Now the same approach. 6 take the numerator equals to the thing inside the root, okay, in this specific form, which is a derivative a times of derivative of the inside thing plus some constant. You will have 6x plus 7 is equals to a times 2x minus 9 plus b. After comparing, you will have a is equals to 3, b is equals to 34. This means numerator can be rewritten as in this form. After rewriting numerator as in this form, you will have this as your integration. Now separate them, you will get one part as this, another part as this, and you know that taking this thing as t, taking this thing as a t, you can directly replace your numerator. Okay, so let's see. So you take this is equals to t. Now dt is equals to 2x minus 9 dx. This means I1, or this integration we are saying I1. So this means I1 will be dt by root of t. This means I1 is equals to 2. Okay, here it must be integration sign. So I1 is equals to 2 root t. This means I1 is equals to 2 of root x square minus 9x plus 20. Okay, now what about I2? I2 the second integration, which is just integration of 1 by root x square minus 9x plus 20 dx. Okay, and this can be rewritten as, if you want to express by completing square method, you will have x square minus 9x plus 20 plus and subtract what, 81 by 4. So then you will get x minus 9 by 2 whole square minus half whole square. So from here you can directly use your integral formula for such type of integrations. You will get log of modulus x minus 9 by 2 plus root of x square minus 9x plus 20. So after substituting both of the solutions, okay, you will get your final answer as this. Okay, I hope that you got this. Let us move to the next problem, problem number 20. Let's see quickly. Okay, so x plus 2 root of 4x minus x square. Okay, now taking numerator is equals to a times of derivative of the thing inside the root, you plus some constant. After comparing, you will get b a is equals to minus half and b is equals to 4. You will get, okay, and then rewrite your numerator in this form, then separate them in these two different integrals. Now evaluate these two different integrals separately. You will get what, I1 will be this integral, I2 will be this integral. Taking, okay, this whole integral will be the answer for minus half I1 plus 4 times of I2. Okay, so let's first evaluate the I1. So I1 can be evaluated by just simply taking this inside expression, okay, the inside thing, okay, root inside thing. So this is just nothing, 4x minus x square is equals to 1. So derivative it with respect to x, you will get 4 minus 2x dx is equals to dt. This means numerator can be replaced by dt by root t. Okay, dt by root t. Clear? It is division. So the integration will be 2 root t. Now replace t. You will have 2 root of 4x minus x square. Simple. I1 will be this. Now I2 will be the direct, which is just integration of 1 by root of 4x minus x square. So completing the square method, you can get this inside thing of the root. You will get 2 square minus x minus 2 whole square. This means now you can directly apply your direct formula for this integration. You will get sine inverse of x minus 2 by a, which is just x minus 2 by 2. Now just put the thing in the given expression. You will get your final answer as this. Okay, simple. I hope it is clear to you. Let us move to the problem number 20 quickly. Okay, so problem number 21, 22, 23 and 24. Okay, and also the 25 now left. Okay, so these problem we will be seeing the solution for these problem in the upcoming session. Okay, so as we do not have the required time for that to solve, so that is it for now. We will be back with these remaining problems. Okay, so thank you all.